Okay. So then there are questions like, okay, what do you do with this? Well, first thing I ask you, what's a y-intercept? Okay, how do you get a y-intercept? That occurs when x is 0, or in this case, when t is 0, right?
Yes.
Now again, people weren't using that consistently in the test. If you made mistakes about getting x and y intercepts, how did you miss that? I'm not saying that in the context of, how could you be so stupid as to have missed that? I'm saying that in the context of, you're not that stupid. You're quite smart, okay? But how did you manage to miss that, okay? What did you do? What do you need to do differently in order not to miss things like how you get the x-intercept and how you get the y-intercept? Or when you use simultaneous equations to find out when two straight lines intersect, okay? People didn't do that. Many people didn't do that. Many people did, okay? So yeah, these are actually kind of little things you just got to get straight on, and then you don't make the mistakes, right? Then you get a much higher score. Okay, anyhow. Okay, so y-intercept is when t equals 0, and yeah, I mean, in the MCR class, somebody said right away, oh, the y-intercept is 76. Yep. Put in 0 for t, and you get 76. So that means your graph has this point. You also know that if what we talked about just a minute ago is correct, that the vertex is at 80, negative 20, because the vertical shift and the horizontal shift are negative 20 and 80, right? So if we've done it all correctly, this thing should prove to have a vertex at 80, negative 20. Okay? Well, is it so? Well, how do you find the vertex of this function? But we did it. What did we learn about the quadratic formula? We learned that the function is 0 if and only if t is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, a formula which you should have ingrained in your consciousness. You should have come to this class with it ingrained in your consciousness, but I know most people don't, okay? Because nobody's ever asked to really remember anything, but now you are, okay? So you really have to have that. You cannot survive the rest of your life without having that firmly ingrained in your brain. If necessary, get a little chip implanted. Well, that's really not quite feasible yet, but it will be soon. Okay. And nobody really wants that chip in their brain, though, do they? Okay. That might change. Okay, well, that's totally irrelevant. The other thing you get from the quadratic formula is where the graph crosses the x-axis. In other words, where this function takes value 0, and where the axis of symmetry is. Do we remember talking about the axis of symmetry in the quadratic formula? Okay. We did. Very clear. You know, if it's not in the videos, I'll eat this chalk. Chalk is relatively harmless, although I don't think it tastes very good. Never tried it. I might find that I like it, you know, addiction. I try to avoid addiction. Now that I think that looks pretty good. Okay, well, your axis of symmetry, remember this picture where I circled the negative b over 2a? We did this, okay? If you didn't see that when you reviewed, you didn't review right. There are many reasons for that. Maybe you just didn't have enough time to do a good review, but the consequence is you don't do as well on the test, right? Okay? So, axis of symmetry is t equals negative b over 2a. So let's just evaluate that. Let's see, what's b?
2.14.
b equals negative 2.4, a equals 0.015, axis of symmetry, t equals negative b over 2a, which is negative of negative 2.4 over 2 times 0.015, which is 80. T equals 80. That's the line here. So here's your axis of symmetry. T equals 80, and by darn, this point is on it. if I don't manage to hit it. Okay? Make sense? So everything comes full circle. So there's a lot of neat stuff that comes together when you actually study quadratic functions, okay? So that's where we are. Now, there's much more I could say about this model, but we'll go on and talk about some of the things you directly need to do for homework.